Let's test another argument for validity using truth trees, and this example is going to use every single rule. So is this argument valid? I'm going to start by constructing my truth tree with the three premises and the negation of the conclusion as the roots. And on the right hand side I'm going to write root because that indicates where I got lines 1 to 4 from. Now I'm going to start by looking for any non-branching rules that I can use because those stacking rules are easiest to do first, but I can't find any, so I'm going to have to start with a branching rule. And I'm going to choose the arrow in row 1. So that arrow rule gives me the negation of the antecedent and the consequent on the other side. That's where I get my row 5 from. That comes from row 1 using the arrow rule, and now I can tick off row 1. Next, well, I can actually see that I can already close off one branch, which is this one here, and that's because I've got the negation of B if and only if C, and I've got that same formula above without negation. So remember, we close branches if we see any formula and its negation, but it doesn't have to just be a letter and its negation. It can be any formula and its negation, because that's a contradiction. So that's why I can close this branch early. Next rule I'm going to apply is the OR on row 5, and so that's also a branching rule where I get each of the disjuncts on each branch. And again, it looks like, oh, and that's where I get my row 6 from. That came from row 5 using the OR rule, and now I can tick off this formula because I've used it. And again, it looks like I can close this branch for the same reason. It's contradicting with that formula up there. So now the next rule I'm going to do, I can see that the main connective in row 6 is an OR, a negated OR. So I'm going to apply the negation of OR rule. So my rows 7 and 8 come from row 6 using the negation of OR rule. And next I can decompose row 8 using the double negation rule, giving me row 9, so that came from row 8 using double negation rule. And I can tick off that since I've now used it. Also I can tick off that since I've used it. Next up, I'm going to actually do row 4. And again, this is a branching rule. Actually, I've changed my mind and I'm going to do row 7, which is the negation of an arrow. So the negation of an arrow is a non-branching rule, which is why I'm going to choose to do it now. And I'm going to end up with D and E, not D and D, and the negation of C. And that gives me my rows 10 and 11, which both come from row 7 using the negation of arrow rule. And I can tick off row 7. And now I can break down row 10, which is just an AND rule, so that's quite simple to apply, giving me rows 12 and 13, coming from row 10 using the AND rule. Now, are there any, well, I'll tick that one off now. Are there any other non-branching rules I can use? I scan my eyes up the branch and no, there are no non-branching rules I can use, so I'll have to use a branching rule now. And I still haven't dealt with row 2, so that's the one, well, actually I'll deal with row 4 first. So that is the negation of an AND, that will give me a branch where I get negation of each of the conjuncts. So I'll get my row 14, and that's coming from row 4 using the negation of and I'll tick off row 4. And now I'm going to decompose this negation of and over here, a negation of or, sorry, because that is a non-branching rule, and giving me rows 15 and 16, and those come from row 14 using the negation of or rule. And remember, this whole time I'm scanning to see if I can close any branches, and it looks like I can. I've got an A and its negation over here, so I'm able to close this branch because that's a contradiction. Right, now I still have formulas rows 2 and 3 to decompose. So I'm going to go for row 2. I'll bring down my branch so I have space to write, and that is negation of a biconditional. So I've got each of the elements of the biconditional, and the rule for the negation of a biconditional is that I negate one of them on each of the branches. So that's where I'll get rows 17, 18. They came from row 2 using the negation of a biconditional rule. And I can tick off row 2 because I've decomposed it. And I'm still scanning to see if I can close any branches, but I can't see any contradictions at this stage, so I can't. So now I will apply row 3, which is a biconditional as well. And since I've got 2 open branches, I have to apply the rule to both of them. And so any rule that you do, you have to apply to any open branches that you have. So we have a biconditional, which means I have either them both true or them both false. And I apply the exact same thing to the other branch. And that's where I'm going to get rows 19 and 20 from. And that's coming from row 3 using the biconditional rule. And now I can tick off row 3 since I've used it. Now remember, what I'm looking for is an open complete branch. All I need is one open complete branch, and that will give me a counterexample. So I've got a few open branches here, but I just need to check whether the branches that I have are open. And I can see that I've got a C and its negation over here, so I can close this branch. And the same thing over here. But on these 2 branches, they are open. I can search all the way, looking at all the atomic formulas I have all the way up to the top of the tree, and there are no contradictions. And same with this one over here. So they're open, but are they complete? And that means, are there any, have I decomposed all of the complex formulas? And yes, I have, because all of the complex formulas have a tick next to them, which means I've decomposed them. The only formulas that don't have a tick next to them are just letters or the negation of letters. So it looks like both of these rows are complete and they are open, which means that they are counterexamples to this argument. Now remember, all I'm searching for is one counterexample, because even one counterexample is enough to show that the argument is invalid. So I'm just going to go and pick this first branch over here. So I've proven that the argument is invalid, and now I can say what my counterexample is. So the counterexample is a valuation, so saying whether each letter in the argument is true or false. And the way I get my counterexample is I just read it off the branch. So looking upwards along this branch, I can see that C is false, B is false, G is false, while F is true, E and D are both true, and A is true, and H, well, there is actually no H in this branch. I can look all the way to the top, tracing it upwards, and there is no H on this branch. And that's okay. That just means that this counterexample doesn't specify what the value of H is. It's still a counterexample whether H is true or whether H is false. So what I'm going to do is just put a question mark because that's an incomplete valuation. So now I've proven that this argument is invalid, and yeah, we used every single rule on the way.